Like I said, you guys are in the big leagues now. Math 1 days, you had standard notation y equals 2x plus 5. Now, we're dealing with that. F is the function name. X is the x value, the input value. Notice the parentheses, put a star there on yours. The parentheses don't mean multiplication. This does not mean f times x. No, no, 1,000 times no. Put a little star on yours. F is just the function's name. So you can really have, you can sometimes have g of x. Or sometimes you can have h of x. It's just the function name. You can name the function anything you want. But it does not mean f times x. It means a function of x, because x is the independent variable. Everything depends on what x is. Everything depends on what x is. Think of warm-up. Think of warm-up. Everything here depended on what x was. I put the x into the machine, the function machine, so to speak, and the machine spit out these values, -1, -9, and by the way, thank you, Cruz, you corrected me. The function at -4, not -17. I messed up on that last one. Just look, you don't have to write this down, but look. -2 times 16 is -32, minus 1 is -33. So this was actually -33. Good looking, Cruz. So the function was spitting these f of x values out, and everything depended on this x, on what x was. You give me an x, the function is going to spit something out like this. So coming back over here, what's in front of you? How do you speak it? Back in the day in junior high, would say, this is how we would say it, y equals 2x plus 5. Now, we're in the big leagues, f of x equals 2x plus 5. That's for you. It's right in front of your face. You're going to keep that in your notes. Back in junior high, when you're a little kid, it was x and y. Now you're in the big leagues, it's x and f of x. But f of x and y mean the same thing. They mean the same thing. This is where we're big leagues now, so we're going to speak mathematics and communicate mathematics in a more sophisticated way. And last but not least, notice when you're in junior high, in math 1 and math 2, you had the x-axis and y-axis. Now you have the x-axis and the f of x-axis. That's kind of strange. F of x-axis. Okay? So y-axis and f of x-axis mean the same thing. We're just now in the big leagues. We're communicating this way. Cool. Rock and roll. There's the jam, but appreciate it. There we go. Go ahead and put that to the side now. Let's get into some notes. Get the other note guide out that I gave you. So get out the other note guide that looks like this. Cool. So we're on the 3.3 note guide. All right, what is function notation? Write this with me. Here we go. So go ahead and write this with me on that first vocabulary word. Function notation is replacing y with f of x or any other function name. Okay? So replacing y with f of x or any other function name. So underneath where it says notes now, I'm going to put example. Y equals the cube root of x minus 70. So making anything up at the top of my head, I'm going to write that down. Y equals the cube root of x minus 70. So Lola, if you want that R sound, you got to be taking notes, just saying. It's up to you though. The cube root of x minus 70. Let's put it in function form. F of x equals the cube root of x minus 70. Or h of x. What if I don't like f? I want to name it h, the function h of x. Fine. It can be any letter. This is the function, the letter's function name, the function name only. It does not mean f times x. The h is the function name. So all we're focusing on is big league articulation of mathematics today. We're not getting to high level math. It's just we're making that shift from y to f of x or g of x or look at, if you flip the page now, look at number 1. Look at number 4, s of x, s of x. 5 is t of x on the other side. U of x, it could be any letter, is my point. Take note of that. So go ahead and flip your page. Let's try number 1. Let's try number 1. I'm actually not going to cheat. I'm not going to do all the directions. They're saying, look, evaluate the function when x equals -4, 0, and 2. Three separate values. I'm only going to do the first one, -4. I'm not going to worry about 0 and 2, okay? Just for our practice. It's a little excessive. Let's just evaluate each one of these functions when x is -4. What do you say? Okay, here we go. Kind of like warm-up. When x is -4, then that means, look at the function at -4 equals, careful, this means -1 times x. -1 times -4 plus 4. So the function then at -4 is going to be, let's see, -1 times -4 is a +4 plus a 4. The function then at -4 is 8. Done. I trust you guys can see that. If not, there's some seats up here. You want to come up a little closer? Let me zoom in a little bit. Question on number 1. Oh, on number 2, g of x. Put this one in red. So g of x equals 5x. So let's figure out the function g of x when x is -4 here again. Here we go. So g at -4 equals 5 times -4. So the function g at -4 is going to be -20. That was easy. Wow. How about h of x? I'll go green for that one. The function h of x. H at -4 equals 7 minus 2 times -4. So h at -4 equals 7 Let's see, negative 2 times negative 4 is a positive 8 if my coffee is kicked in. Right, Cruz? So the function h at negative 4 is going to be 15. Nice. Again, on the directions, they're asking to do 3 values. I'm only just doing negative 4 for all the functions, just seeing what the output is. Just what is the value of the function when x is negative 4? How about s of x? Here we go. I'll go Dodger blue again. The function s of x, what's s, the function at negative 4? S at negative 4, 1. We got 12 minus 0.25 times negative 4. So 0.25 times 4 is going to be negative 1. My coffee is kicked in. So the function s at negative 4 equals 12. Negative times negative is positive 1. .25 times 4 is a positive 1 because this is a plus, this is a negative 0.25. Careful there. I got a negative times negative, that becomes positive 1. So the function s at negative 4, ladies and gentlemen, is going to be 13. How about t of x? Number 5. T of x. T of x, how about t at negative 4? It's going to equal 6 plus 3 times negative 4 minus 2. Let me fix my chicken scratch. 3 times negative 4 minus 2. Sanchez, you with me? T at negative 4 is 6. I got a positive 3 times a negative 4, I want to say is a negative 12 minus 2. I'll just go from left to right. T at negative 4 is going to be, 6 plus negative 12, I want to say is a negative 6. And then I got a minus 2 now. So t at negative 4 is going to be a negative 8. Again, assuming my coffee kicked in. I'm craving some coffee, by the way. Where's my coffee cup? There it is. Last one. U of x. So u, the function u at negative 4 is going to be negative 2 minus 2 times negative 4 plus 7. So u at negative 4 is going to be negative 2 plus 8 plus 7. A negative 2 times negative 4 is a positive 8, and my coffee is kicked in. So u at negative 4 is going to be negative 2 plus 8, I want to say is 6, plus a 7. So the u at negative 4 then is going to be 8, 9, 10, 11, 12, 13. I told you I was bad at mental math. I was not a math major. I was a philosophy major. Horrible at mental math. So if you're bad at mental math, be encouraged. I'm a math teacher, and I'm bad at mental math. Go figure.